This video will provide a detailed demonstration of the entire process of programming the driver for the WT99P4C5-S1 development board. For this video, you need to have a development environment of the ESP32-P4 master version in advance. Wireless DAG WT99P4C5-S1 development board based on the wireless DAG WT0132P4A1 module and equipped with the Espressif ESP32-P4 chip. It is a full-featured audio and video development board with low-cost and low-power consumptio. 1. Interface display. The interfaces involved in programming this development board are as follows. 2. Firmware compilation. Enter the following URL in your browser. Navigate to the page. Download the compressed package of the driver code for the WT99P4C5-S1 development board and extract it to the directory covered by the ESP32-P4 environment. Enter the following commands. Navigate to the peripherals directory of the driver code, then execute the compilation by entering the IDF build command respectively. Compile the basic examples. Compilation succeeded. Compile Ethernet. Compilation succeeded. Compile the HID USB. Compilation succeeded. Compile the test PID USB. Compilation succeeded. Compile IFAN-S. Compilation succeeded. Compile the SD card. Compilation succeeded. Compile UART. Compilation succeeded. Compile the screen and camera. Compilation succeeded. 3. Programming and verification. Insert the USB programming interface and connect the other end to the USB port of your computer. Then turn on the switch. Enter the IDF flash command in sequence. The system will program the compiled firmware into the development board. Program the basic examples. Programming completed. Verify the basic example. After programming is completed, enter IDF monitor and check the logs. The logs should show Hello World. Program Ethernet. Programming completed. Verify Ethernet. Connect an Ethernet cable to the development board. After programming is completed, check the logs, which should display the Ethernet IP address. Program the HID USB. Programming completed. Verify the HID USB. After programming is completed, connect a mouse to the development board. The logs should show the XY axis movement data and left/right button click status of the mouse. Program the TUS HID USB. Programming completed. Verify the TUS HID USB. After programming is completed, the logs show that the mouse moves in a clockwise rotatio. Program IFAN-S. Programming completed. Verify the speaker and mic. After programming is completed, connect a speaker. Speak into the microphone, and the speaker should output what you said. Program the SD card. Programming completed. Verify the SD card. After programming is completed, power off the board. Insert an SD card. Power on the board. Remove the SD card and read its contents. The documents foo and ni-hao should be added. Program UART. Programming completed. Verify UART. After programming is completed, power off the board. Connect an RS-485 line driver and connect the line driver to your computer. Open a serial port debugging assistant, which can be downloaded online. Observe the serial port status of the RS-485 line driver. Power on the board, and you can observe the 485 data interaction on the serial port debugging assistant. Program the screen and camera. Programming completed. Verify the screen and camera. Connect the touch screen. Pay attention to making sure that the blue side of the flat cable faces upward and the silver side faces downward. Remember to cut off the power before connection. Connect the screen, ensuring that the black side of the cable faces up and the gold side faces down. Reversing the connection may risk burning the screen. Connect the camera ensuring that the black side of the cable faces up and the gold side faces down. After the connections are completed, power on the board, interact with the camera, and the screen will display the images captured by the camera. At this point, the programming and demonstration of the driver for the WT99P4C5-S1 development boards are all completed. Wireless Egg, AI Agent Hardware Specialist.